Hello, my name is Danny Beard, and this is my presentation on the VX5001 3D for Visual Effects Pro module here at Escape. The project brief was as followed: to create a photorealistic 3D VFX shot of an object that has been tracked onto a backplate with a frame range of 150 to 200, to record a presentation explaining your processes and approach for the project, the applicable softwares were 3D Equalizer for camera tracking, Maya and Arnold for modeling and rendering, Substance Painter for texturing, Nuke for exporting, and you will learn to track the chosen shot and then build, texture, light, and render your 3D asset. You will need to produce the necessary rendered elements for the 2D pipeline, which we will use in the next module, VX5002. This was the mood board that I created to explore ideas for this project. To understand the basics of camera tracking, I used this shot of a camera orbiting a desk so that I could replicate its movement in 3D Equalizer. Manual tracking requires you to place individual points using either a marker or pattern tool to calculate the location of an area in the backplate. Automatic tracking is much more efficient at getting a smoother track, however you lose the ability to customize the track to your specifications. After deliberating on my ideas, I decided to make my CG asset a replica of the Batpod. The Batpod is a vehicle used by Christian Bale's Batman and Anne Hathaway's Catwoman in The Dark Knight and The Dark Knight Rises. These films, directed by Christopher Nolan, took a much more realistic approach to the Batman character, giving him technology inspired by modern military vehicles. To ensure I could effectively replicate this vehicle in Maya, I collected several images of its profile as well as orthographic sketches. My original plan for the backplate was to use my own, however, after making the error of recording on iPhone, it made it very difficult to get a smooth track in 3D Equalizer. This meant I had to resort to using the Escape video library. With my desired model in mind, I chose a backplate which best represented a version of Batman's Gotham. After setting the correct film back, I used the parameter adjustment window to check the camera's focal length and distortion. Having the undistorted plate is key in creating a believable integration. To ensure the camera is tracked accurately, I had to constantly use calculations to lower the deviation of my points. The industry standard for the deviation browser is 0.5, and I managed to get my manual track to 0.44. The curved red line indicates the camera's movement in correspondence to the backplate. These are my lineup and 3D orientation views that can be seen in my 3D Equalizer file. Here is my manual track with cones to represent my tracking points. With my backplate tracking complete, I started blocking out the largest components of my CG asset. I began modeling the fuel tank as it's the central component in which a majority of the bike is connected to. I had to redesign this piece several times before landing on a final shape due to the lack of visibility of this section on my references. After starting with a primitive cube and cylinder, I retopologized everything using the quad draw to create one clean component. The tyres of the Batpod are the largest parts of the vehicle, and so I had to make sure their topology was clean, with the added difficulty of the tread's unique pattern. The base rubber of the wheel was made using a pipe with added edge loops to give the sides a bulge. This helped make the tyres look inflated. There are many different ways to produce objects around a curved surface, but I decided to use quad draw and duplicate special to revolve the tread pattern around the face of the wheel. This method allowed me to easily edit all of the treads at once to get the distinct plus pattern on each square. Once the main frame had taken shape, I used bender formers to block out the curved surface of the silver plating that covers the central body of the bike. The front panel was particularly complex due to the two circular arches that protrude out of the end. These arches help to contour around canisters that sit below the paneling. My topology, while even, could definitely be improved on these pieces, as the lack of a bordering edge meant that smoothing it produced sharper edges. Booleans are a useful tool that can divide and combine components based on their geometry. The disadvantage of using Booleans is that they often ruin topology, so after using them I had to use the multi-cut to flow edges around the newly created shape. Most of the backpod is made up of separate joints and plates that I made by quad drawing on live objects. In a similar process to the silver plating, I had to use bend deformers to create both the arm guards and the seat. These pieces were more challenging than expected, as curving geometry makes it difficult to add surface detail without creating n-gons and tries. The bike's pedals, handles, weaponry, and axles all had to be created separately so that they would look accurate to the source material. Several pieces such as the cannon silencer and the foot pedals had holes which needed to be enforced with holding edges. These can be implemented with either bevels or the multi-cut tool. The throttle and splash guard were created by extruding a sequence of faces with a channel running between each one. This made a raised grating that would be amplified with ambient occlusion when it comes to texturing. The backpod has several wires and piping weaving throughout its mess of metal plating. I had modeled these using EP curves and sweep meshes. Once the mesh is created, I use the control curve point on the curves to refine the wires and give them realistic bowing. The component which tested my modeling abilities the most was the front cannon holder. This piece had to have 4 different sized circular openings that flowed into a sharp dynamic base. The best way I found to approach this was to intersect multiple cylinders into the base shape and then quad draw everything together. This took many attempts, as flowing the edges from the circles made my topology very messy and dense on the rest of the piece. The final component definitely isn't as accurate as I had hoped, but it has given me insight into how to better approach an object like this in the future. These are my major stages of my modeling process. And this is the final wireframe of my backpod. UV unwrapping is a tedious but crucial part of preparing a model for textures. I focused on unwrapping the largest components first and ensuring that the checker map was even to avoid any stretching. I also made sure to increase the textile density and separate components by UDIMs depending on their distance from the final render camera. Here are my final UVs for this model. To ensure a smooth transition into Substance Painter, I assigned a different color lambda to certain components of my bike. Each color represents a physical material that the components share. These lamberts were only applied to the high poly, and an AI standard surface was applied to my mid poly. To help with this process, I clearly labeled all of my components in my outliner. I had never used ID maps to texture before this module. However, I now understand that it's a much more efficient way to mask out components based on their material. This exercise conducted with a V8 interceptor model helped me to effectively mask and apply effects to certain areas of the mesh. Due to the backpod being a fictional vehicle, I researched the look of real materials so that I could replicate them in my texturing. The above images depict stainless steel, tarnished aluminum, used rubber tires, matte fabrics, and painted metal. So that I could transfer my lamberts from my high poly to my mid poly, I baked them as an ID map. This meant that I could texture the separate materials using a color selection mask with the ID colors. By using fill layers, masks, generators, and filters, I was able to create accurate textures with realistic weathering. More intricate designs required me to create my own alphas in Photoshop. An example of this is the Hoosier logo that is seen embossed on the tires. After making the logo pure white, I bent it around the curvature of the wheel, using the warp tool. This was exported as a PNG and then imported into Substance as an alpha. By making the brush stencil the outline of the alpha, I was able to use height to give the illusion of the Hoosier logo being raised from the surface of the tire. These are my Substance Painter layers that make up each of the materials on my final model. Each folder is masked through a color selection of my ID map and is labeled accordingly. To improve Substance Painter's performance, I worked with 2K textures and then converted them into 4K for the final export. Using the one master material allowed me to easily switch resolution for all of the components. Here is my final textured model in Substance Painter as well as its UVs. After exporting my textured UDIMs, base color, roughness, metalness, and height, I prepared my model in Maya by assigning all components to a singular AI standard surface. Using the UDIM Mari tiling mode, I was able to connect all my textures attributes to a single material node in the Hypershade editor. To add more realism to the shot, I added 2 disc area lights into the headlights that I modeled in the cannon holder. So that my HDRI was suitable for lighting my Maya scene, I had to use Nuke to paint out the person and the camera tripod that was visible in the shot. As the image was taken using a mirror ball, I used a spherical transform node to convert it into lat-long format for the export. Using grey VFX balls is an industry standard technique that helps capture light direction and shadows for a shot. With help from an image of the grey ball on my backplate, I replicated the sky color and exposure as close as possible by matching it to a CG grey ball. To know the exact placement of the buildings in my backplate, I made a simple blockout using my tracked camera to align meshes to the surroundings. This step helps to ensure that any reflections or shadows cast onto or from the bike interacted with the environment properly. Once this was complete, I scaled and positioned my bike in the most optimal spot in which the camera showcases its full presence. To prepare my shot for the compositing module, I had to create multiple render layers with collections, telling Maya when to include and exclude meshes in certain passes. This is done by toggling the primary visibility absolute override on each collection. AOVs allow renders to be separated by shading elements so that the compositors have more customization when it comes to lighting and integration. Before rendering, I made sure to set my resolution to the dimensions of my undistorted plate from 3D Equalizer. To ensure that my render layers had exported correctly, I checked each pass in Nuke. And here is my final master layer render for this module. These are my final still Arnold renders that showcase the detail I put into this model. Having completed this module, I can confidently say that I've met the project brief, as well as having taken extra steps to ensure my work was presented to a high standard. This was obtained through effective time management and long working hours to refine my abilities. In contradiction to this, there are many things I could have done differently that would have streamlined my workflow and provided me with a better result. This includes sourcing more references for the internal components of the backpod, so that I could more accurately replicate the overall design. With proper preparation, I would have liked to have used my own recorded backplate. This unfortunately was not possible due to time constraints. The iPhone footage I had shot had auto exposure, which caused flickering, and did not work for the tracking in 3D Equalizer due to insufficient camera specifications. Overall, I have been able to produce a close to photoreal object that is properly prepared to composite onto my backplate in the next module. Thank you for listening.